Alright, question 7. The polynomials p and x and q of x have degrees p and q respectively, and p does not equal q. What's the degree of these ones? Now, I'm going to take you back up to the theory, and we're going to use these two to help us out. And then I'm going to give you some examples. So this theory is what's going to help us. But for example, for 7a, well, p of x could be x to the p plus 3x to the p take 2, whatever. We don't actually need to know its degree. P of x degree p, q of x degree q, and for I, the product degree p of x times q of x equals the degree of p plus the degree of q. Didn't need that bracket. So we've got p plus q, that's it. For number 2, for the sum, so we've got p does not equal q, so we can use, I'll do this in yellow, this. Degree p of x plus q of x equals the max between p and q. That's an F, by the way. Max of p and q. For 7b, if degree p was the same as degree q and it equaled p, then the product equals, well, it's going to be p plus p, which is 2p. The sum is going to be the max of p and p, which is just, well, p. They're the same number, the maximum of them is that number. And 7c, give an example of two polynomials, both of degree 2. So remember, degree 2 means it's like x squared is the biggest one, so we could have had 3x squared take 7x plus 8. If we want the sum to have degree 0, then we kind of have to get rid of all the terms except for the constant term. So for example, my first one could be that. My second one would then have to be like, well, negative 3x squared plus 7x plus 1 or something, because then if I added them together, I'd have 3x squared take 7x plus 8 plus negative 3x squared plus 7x plus 1, which would come out as 9. So, which has degree 0. So I really just wanted stuff that would end up cancelling out. It doesn't matter what you put, as long as it all cancelled out. That's question 7.